Cool. So this will be interesting for a couple reasons. One, I gave my first virtual talk ever like last week. So I'm used to being, I told Pete a bit ago, like standing up and walking around and doing a thing. I may end up doing that if I feel like I need to like go. I'm going to try and see what happens if I just sort of sit and visit in a slightly more relaxed way. I'm sitting in an office building that we have a family business as well, and so it's our building, so I can be here safely because only families are around. I gave my NDC Porto talk last week here in the other conference room, and I asked it, I was like, hey, can I go ahead and do it here instead of at home, so I'm not, you know, going crazy at home with the kids. And my father, who's here in the building, he says, sure, but here, let me do something for you. And he takes a sticky note pad and he says, maybe stick this on your computer for while you're speaking. So for those of you, and there's several of you who know me reasonably well on the call, I'm loud, and I talk a lot and I talk fast. And I'm used to being up when I give a talk and projecting. So there's no way I'm going to be a little quieter unless I sit. If it is a problem, I still have an Instapot box sitting here in the office that I can drop the laptop on and stand up. But the other thing that'll be different from the last couple of times I've given this talk is it's been long enough now. I used to give the talk from a standpoint of, okay, well, most people seem to still be kind of dabbling in ASP.NET Core 2.1, and people were starting to look at 3. And so I was kind of talking through stuff that you would see in 2, and then just explain a few things that had changed. There's not that many major differences, the biggest thing being host. So this will be a little different, where I'm going to start from the assumption that we're on 3.1, which is the current long-term support release. And I will, for people who are still maybe looking at 2 or looking at both, I'll kind of take a step back and say, if you're used to seeing something in ASP.NET Core 2 instead, and it looks different to you, here's why. So hopefully that'll work out okay for everyone, and that's cool. And if there's issues or concerns, shout them out, unmute. I don't know if you are able to unmute yourselves. I think you can, or put it in the chat, and Pete will be watching, and we'll roll with it.
Yep, sounds good.
Questions, concerns before we start? Like anything anyone wants to specifically talk about or make sure we're going to cover, or has questions, you can feel free to ask now or whenever.
Everybody good? All right, awesome. We'll go ahead and get started.
Okay, let me do this then. 1 moment. Oh, hey, a free Keynote update's available. That's nice. Not right now. All right, share screen. There it is. And hit play. We good? Everyone see it? Awesome. So, all right. So I kind of already started asking a couple of questions, right? Like where people are right now in terms of their journey or their use of ASP.NET Core. What I didn't ask, and now I can't see the thumbs ups, but I can see like 6 of you who could raise your hands, or in general, like who is still actively maintaining code in like traditional ASP.NET as well? I see Gaines' hand. I don't know if anyone else, or for that matter, has ever done it. I assume that probably the majority of people who are on here, or at least the majority of technical people who are on the call, have done stuff with ASP.NET, whether it's web forms, SignalR, web API, MVC, all those kinds of things. So thinking back through the history of, I am still going to use a clicker, even though I know that's weird, because at least then I don't have to keep reaching forward and tapping. And that's what I'm used to, so bear with me. Thinking back through the history, right, of ASP.NET, you know, we relied a lot when we talked about configuration and setting our applications and managing our applications. We relied a lot on things like global ASX and webconfig, right? Any of us who spent recent months of time in ASP.NET land have lived with these files, and some people may think they're great. I never really enjoyed them at all. Webconfig we'll come back to in a bit. I hated messing with webconfig. I still hate messing with webconfig. But even global ASIX, with sort of the event-driven system, you know, application start, application end, application begin request, end request, app init. All these event-driven systems and the way ASP.NET evolved over time caused it historically to be really tightly coupled. Right? ASP.NET historically was built as a tightly coupled web framework. Everything about the way ASP.NET was built was done such a way that our application code, our framework, was tightly coupled with the web server. It was meant to be run on IIS and Windows. I mean, that's what was it built for, and that was fine, I guess, for a long time, but less than ideal. And over the last many years, I mean, predating ASP.NET Core, we've been moving towards this idea in software development, software architecture, that we want to take those ropes, take those knots, and separate everything, right? We want to have better separation of concerns. We want to decouple our application from our server. It's the same as we're looking at, breaking things. It's the same idea that underlies things like containers and microservices, where we'd rather have individual, clear components that we can then mix and match together to put together the applications that we want and compose them the way that we want. And with traditional ASP.NET, that was always really hard to do. Did anyone ever do anything with Owen at all? I don't know if anyone's hitting thumbs up because I can't see, but so I don't know if anyone messed with this. See a couple. Okay. my Keller, you did not. I saw that thumbs up, but I know you didn't. but thank you. So Owen was an early-ish attempt at the ASP.NET community and .NET community to provide a way that would start that decoupling process. The big idea, the philosophy, and Owen, even though there are individual, there's a Microsoft Owen framework, there's an implementation, but Owen itself is really a standard, it's a spec. And the idea behind Owen was that you could easily mix and match and have your applications be completely decoupled from the servers that they're meant to run on, so long as everyone could agree upon like a uniform global interface for them to share. So it implemented like an iServer interface. And what Owen did is, instead of relying on things like global ASIX, you could have a startup class, which if you're using ASP.NET Core sounds familiar. You could have a startup class or a class that you would decorate with a startup attribute, and that would serve as the entry point for your application. So instead of relying on application init events, application start events, you would just pick an entry point and configure your services in your application as you see fit through an Owen startup. There's lots of different implementations of Owen. It led to a lot, I mean, there's tons of frameworks built. I just saw the last couple of days that several weeks back, Nancy, I don't know if anyone used the Nancy FX framework for web stuff. It was a pretty cool alternative to MVC, to ASP.NET MVC, that was based on Owen. It could still run on IIS as long as it was compatible with Owen, it worked. Now, there was some uptake with Owen. It was kind of all the rage in the Microsoft community. And ASP.NET Core takes it a step further. But ASP.NET, it's not built on top of Owen, although it is compatible with Owen. And ASP.NET Core takes the same general idea and says, if we define a way that we can have an entry point that is based in a startup class and an interface, an iStartup that we understand, an iServer that we understand, that everyone can talk to, then not only can we decouple and get rid of things like global ASIX or web config, but we can also set it up so that ASP.NET can run on Linux, right? It can run on the Kestrel server, but it can run on other servers as well. It can run on AWS. It can run wherever we want it. We can self-host it. And that's kind of the idea behind it and how we get to the, but in order for that to work, we need to have that understood central way that we manage our hosting, our configuration, our services, our middleware and pipelines. How does that all work? The way that happens in ASP.NET Core is through two primary classes, right? We have our program class and we have our startup class. And the program class defines our entry point into the application. And then the startup class allows us to set up all our configuration if we choose to have one, keeping in mind that you don't really even have to have a startup class if you don't want. So the way I want to do this is, the overall flow of this talk is we're going to say, I think we're not going to look at anything that you've never ever seen before, probably for most of you, if you're already working in ASP.NET Core 3 today. But everyone, when you set up your ASP.NET Core application, you walk through and I need to set up this, I need to set up Key Vault. Well, how do I do that? And you follow the instructions. I plug some things into a configure method, my setup, and I don't necessarily know what's happening behind the scenes because there's a lot of helper methods. There's a lot of stuff that happens when an ASP.NET Core app kind of bootstraps itself and spins up. And so the idea behind this talk is we're going to say, well, what is really happening behind the scenes? What's really going on when we create a host and then we run our startup, we configure our services, we configure our container, the service collection, we configure our middleware pipeline, what's really happening? And then how can we tweak that to do our own thing in it? That's the idea. starting off with the host. I know that the talk is mostly about configuration, DI, and middleware, but to even get there, we still have to first talk about the host itself. And the host, when we talk about ASP.NET Core host, is think of it as an object, just an object, that encapsulates all the different interdependent services, dependencies, that our application is going to need to run. The host encapsulates our logging. It encapsulates our dependency injection system. It encapsulates the application startup and shutdown and the communication channels between our app and our server. It takes all these different things and it kind of wraps it in one object to manage all of it. And the reason for that is because we want our applications to be composable. We want to be able to pick and choose the pieces that we use. But at the same time, because we don't have a global ASAX type scenario, we can just have an application end where things just close down all at once. The host allows us to encapsulate that and still have graceful shutdown, graceful startup and shutdown, where everything is still coordinated in a certain way. So what does that look like? This, if you're on ASP.NET Core 3, well, hopefully 3.1. If you're on 3.0, remember that's not long-term support. So when I say ASP.NET Core 3, I'm assuming 3.1. If you're on 3 anyway, you should probably be on 3.1. This would be the standard template for building a web application with ASP.NET Core. So for most of you, you've probably seen this before. What's really happening here? The program class, as we see, has two methods. The main method is our entry point. That's where the application is going to start. But nothing is very exciting is really happening here. We're calling another method, this create host builder. We're getting something back, and we're going to build what we get back and run it. And that's how we're going to kick off our application. But what's happening here? So the create host builder, even that looks relatively innocuous. We're calling a create default builder method, and we're going to configure some web stuff. We're going to set up a startup class, and we're good. But let's drill into what this thing is. Because the create host builder is, first off, going to return an iHost builder. That is the thing up in the main method that's going to be built and run. And we're creating a default version of it off of this host static class. The iHost builder is like a factory. It allows us, again, to compose the pieces we want, set up our configuration, set up and configure a server, set up and configure our configuration, all sorts of things, and piece this stuff together the way we want it, in the order that we want it, so that when it's all said and done, we can build that thing. It'll compose the host for our app to run, and it'll kick it off. And specifically, by default, the templates tell us to call this host.createDefaultBuilder. I'll mention this a couple of times, but remember that all this stuff's open source. Right? ASP.NET Core is open source. And it can be pretty neat to dig in and see some of the things that happen behind the scenes, because actually quite a bit happens when you call the createDefaultBuilder method. It's spinning up a host builder, but then among other things, just by creating the default builder, we are getting an iLogger factory ready and configuring some logging so we can output debug to the console. We are going to a whole bunch of default configuration providers, which we'll talk about a little bit later, reading things like our environment variables and our settings files and our user secrets and that kind of stuff. And it's setting all that up for us and configuring that. It's getting user secrets set up for us when we are in when we're in development. It's doing all sorts of stuff. It's actually, in some respects, even the web defaults portion of it is even setting up our web server for us using some defaults there. So create default builder actually does a whole lot under the cover, so that all we have to do is say, hey, give me the default version of that, and go. Now, all that being said, there's a couple tricks here. First off, you don't have to use that at all. You don't have to use it at all. If you don't want to use the create default builder, all that's doing is returning an iHost builder. Well, I can make my own. So if you don't like some of the stuff that comes in the default, you don't have to use that. Now you can use it and then override it, add additional stuff to it and add tweaks, but some things aren't easy to undo, right? There's no like just kidding or disregard extension method off the host builder. An example of that would be when we talk about the configure web defaults, right? Configure web host defaults is going to set up Kestrel as our web server. It's going to set up IIS integration as a reverse proxy to our web server. It's going to set up additional configuration values for managing our web hosting environment. And what if, even though I know I can add more configuration, I can tweak things, what if I don't want Kestrel? I can't say use Kestrel, just kidding. So instead, we can create our own host builder. And similarly, we don't have to call configure web host defaults. You can just call configure web host. The difference here being that now, instead of having all the setup stuff like our content route and setting up our web server and all that, we're just getting an empty one. We're saying, hey, I need some web stuff and I want to configure it, but don't use any of the nice defaults that maybe the Microsoft folks assumed that we would want. Now, in this example, I'm still putting a lot of those same things in. I'm setting up a content route, but I can pick a different content route and pass whatever string in there that I want. I can still say use Kestrel and use IIS integration. Maybe I want to pick a different environment and I don't want to be in development. I want to specifically say I'm in a staging environment. Okay, those are some of the things that we might see as defaults anyway. The point is I can use other stuff. Let's look for a second the IIS integration. That is a default, an assumed default. But what's really happening there is, and normally you don't see this line, right? Normally you just see configure web host defaults and then we use startup. But what is happening is we are turning on IIS integration. When we enable that, we're making IIS our reverse proxy that sits between our web traffic and Kestrel. Kestrel is a very lightweight server. Features have been added to it over the last few years. It's become more robust. Initially, it was suggested that you should never use Kestrel as your edge server. It's still generally suggested that you probably don't want to. The reason for that is a few things. Even though there's more features in it today, Kestrel doesn't have great support for managing concurrent connections and protection against that. It doesn't have great support for load balancing. It doesn't support running and hosting multiple processes or applications off the same IP and same port. So if you need load balancing or you want to support multiple processes like that, Kestrel doesn't really do that. It doesn't have super support for managing things like images and static files. So rather than making ASP.NET and Kestrel do that, you can use something like IIS as a reverse proxy to sit in front of it to do some of those things, because something like IIS is better at that. You can handle load balancing. IIS is going to have better support for managing SSL. And so you can have all those things and terminate your SSL and your load balancing and all at your reverse proxy with IIS, and then pass through the request into Kestrel and let Kestrel do what it does best, which is as a lightweight web server, receive that request, configure it into an HTTP context, and then hand that off to your pipeline to start letting your application do what it wants. But IIS isn't the only thing. What if you want to run, say, in a Linux container? Well, you don't have to use IIS. So you could use Apache or you could use Nginx. There are other options. You don't have to use IIS as your reverse proxy. And similarly, you don't even have to use Kestrel. Has anyone hosted ASP.NET like on a host that isn't Kestrel? Has anyone on this meeting done that? Anybody? Or I don't know. Again, I can't see many people. Are we getting any thumbs? I'm assuming not many usually.
Yeah, not too many.
Yeah. So, but you don't have to use Kestrel. You can, you can use like HTTP/sys, which is a Windows-only server. Any server that is compliant with the iServer interface and is OWYN compatible will work here. Okay, so one last point about this is for the handful of people who are either still using ASP.NET Core 2 now or in the past, or if you haven't looked at ASP.NET Core 3 at all, whether you're using configure web host or configure web host defaults, that was new with ASP.NET Core 3. And so this kind of look, the new host builder or the iHost builder or the iHost.configure defaults or whatever this piece, the create default builder and configure web host defaults, this looks different in ASP.NET Core 3 than it did before. And the reason for that is because, I zoom back ahead again for a moment, is because the iHost builder is what we call a generic host. The generic host was new. It started getting floated around in ASP.NET Core 2.2 and in the 3.0 preview. The generic host idea is that iHost doesn't have to be used for web at all. It doesn't have to be used for HTTP at all. So you can build ASP.NET applications that sit in a data center or sit in the cloud that are strictly for messaging or doing background tasks or any other kind of workload that isn't HTTP focused in the first place. And the thought was, if we're going to ask people or encourage people to use ASP.NET in these scenarios as well, why should our host builder assume that you need all of the extra load of configuring and having web-based things in the first place. Why are we setting up Kestrel and listening for HTTP requests and doing all of the background work for that if you are going to be hosting an ASP.NET application that doesn't need it? And so iHost is the generic host that allows you to not have any of that stuff at all. So you don't have to configure web defaults if you're not building a web application. Prior to that, you would have seen the iWeb host builder. And so if you're working in today or previously worked in ASP.NET Core 2.x, your program class may have looked more like this. So this might look more familiar to those of you who aren't in 3 yet. So instead of the iHost builder, right, we have the iWeb host builder. Instead of the host.createDefault builder, we have the web host.createDefault builder. And we don't have all that extra chunk. We don't have the web builder and the configure web host default stuff. None of that's there. This was actually simpler looking, right? Like it was easier to do because it was all in one thing. It was all one builder. But the downside was, again, it was less flexible. And we're trying to separate out and be even more granular in the way that you can build ASP.NET Core applications. So that's why they changed, and that's why we use the generic host today, whereas in the past, we saw this web host instead. Okay, so that's the stuff with the host. Now let's get to the maybe slightly more interesting stuff and talk about configuration across the entire application. So who loves web config? I already said I don't. Does anyone love web config? Who misses and wishes they could spend more time working in web config and trying to figure all that out? You know, with its thousands of lines of XML and system web server stuff and app settings and all the XSLT transforms, and who loved all that? Anyone? Like I didn't. Now, one thing about web config, in addition to all that web server stuff, is we had these chunks like that bit there at the top. We had our app settings elements. And really all that was a whole bunch of key value pairs, right? We would just stack all these things in and all the different configuration settings, stuff that we would need for our ASP.NET application, we'd stick there. And we might have a development version or a production version and put transforms on our web config, but then all of our application config was there. There's a couple problems with that. Aside from the fact that I just don't, me personally, I always hated the whole format and I never really loved web config in the first place, is the worst thing is this is being checked in. I'm checking this into source control. And so I don't necessarily want all my application settings in source control. What if I have connection strings? I mean, how many times have people, I know I did it. I mean, how many times have people added a connection string in app settings in a web config, even though you kind of knew you didn't really want it there, and it probably had passwords or some sort of auth information there. And then you checked it in and maybe later said, oh, shoot, I just checked that into source control. I wish I didn't do that. I did that all the time. Maybe it's just me, but I bet it wasn't. And that's okay. Like we've all done it. Well, the ASP.NET Core web config is gone. It's not truly gone because, say, if you're using IIS in any fashion, IIS still depends upon it. I mean, you might be using web config for other things, but for your application configuration, we're not depending on web config anymore. And it's been replaced with a whole lot of configuration providers, tons of them, and different types of configuration providers that can all be mixed and matched and laid on top of each other. And there's a bunch of them. Now, by default, when we configure our host default, for example, our web host defaults and the default host builder, we're going to get a handful of these set up for us behind the scenes. We're going to get our setting files configured for us. Those are things like app settings. We're going to get user settings configured for us by default, which is available in development anyway. We're going to get our environment variables made available to us and command line parameters if we have any available. Those are all the defaults configured and in that order. And there are others as well. First, I want to talk through what each of these are and how they work. And then we'll maybe look at a couple others that are available and the ways you can tweak the standard settings and the standard configuration. So first off, settings files. Oh, by the way, one other thing about this, and I'll come back to this point. I know I already said that this is the order they get configured in, but what that also means is that they get read and loaded into configuration in that order, which means that if you have naming collisions, that's okay, and she can be the last one in wins. And we'll see what that looks like as well in a second. So let's start off with app settings. The app settings file is just a JSON file. If we've done anything in ASP.NET Core, if you've done this before, you've seen your app settings file. It's very simple. It's a plain text JSON. But you also are going to have environment-specific app settings files, or you can. So we can have an app settings.development.json, .staging.production. And each of these is going to be loaded. The parent, the app settings JSON file will get loaded first by default, and then our environment specific app settings will be loaded after that. And they're very simple looking files that we can put in. I'm going to come back. I know we use foo for everything in our industry. We're going to have a bunch of stuff around a foo service that we'll keep coming back to for some of the, because I try to keep these code samples very, very lightweight and simple so that we can focus on the ideas and not worry about what's really happening in terms of the application itself. So imagine I'm going to have some sort of foo service and I need to configure it. Well, the foo service settings, I'm going to give it a couple of foo service settings with maybe a URL to reach out to some API and some sort of a timeout. Okay. Notice these things can be nested, right? And then I'm going to also have just a setting one. Now this is a JSON file. It doesn't have to be all strings. We can have Boolean values in there. We can have number types in there. So timeout, you'll notice, is not a string of 60. It's the number 60. Okay. Easy enough. I think everyone will understand that's just a simple JSON file. That's how we're loading up some settings. But we can also have a development version of that. Maybe the development settings, JSON version, we don't have the setting one. That was just there. We don't worry about it again. But maybe in our development version of app settings, we have a different URL. Maybe there's a dev API. That's fine. So again, remember, we're going to load these in order. So app settings gets put into our configuration first. And then after that, app settings.development.json will be added to configuration. It's going to see there's a foo service settings.url, and it's going to let this one override the original. So if we're in development, this will be the URL that gets used in our config and not the original one. And then I can add additional properties. So now I've added a rollback property. Maybe I don't want to really commit anything. I'm not persisting anything to a data store. So by default, I didn't even have a rollback property in my config in the standard parent app settings file. But in development, I want to specifically say I have rollback. And so that's fine, because not only will it overwrite, but it'll merge all those things together. The end result being that I have a timeout and a dev URL and a rollback all mixed together under foo service settings. That's really all there is to app settings. Now, I already talked about web config and the idea of committing, say, our connection strings and our credentials and stuff to source control. So what if we have secrets? What if we have credentials and we don't want them right there in app settings? We don't want them to be visible to anybody. Well, that is where user secrets comes in. User secrets is actually pretty cool. Remember, it's only available in development. You don't use user secrets in prod. But user secrets is a way for us to take sensitive configuration, sensitive settings like our credentials and our connection strings and keys and stuff like that, and put it somewhere outside of our solution altogether. And it's pretty easy to set up. Here's what's really happening behind the scenes. First off, you have to have a user secrets ID. Without that, you have no user secrets. The user secrets ID goes into your proj file. So it's project specific, not solution specific. Knock my keys on the floor. So if you have a solution that has 10 different projects in it, there's going to be separate user secrets, a separate user secrets store for each individual project. So I go into my project file and I add a user secrets ID. It does not have to be a GUID. The standard convention seems to be people use GUIDs. You don't have to. You can use something else if you want. Now, once you assign a user secrets GUID, you can modify secrets in a handful of ways. If you're using Visual Studio or VS Code, Visual Studio, it comes in by default. VS Code, as with most things in VS Code, you get a plugin, but there is a plugin for managing your user secrets. You can right-click on your project file and you can edit your user secrets right there. I actually like to use, and I'll use that sometimes, I actually like to use the CLI because you can use the CLI anywhere. And so there's CLI tooling around user secrets. So if you start a brand new project, and then you go out to your command line, and you type .NET user secrets list, one of two things is going to happen. Either you're going to get this response, there are no secrets configured for this application, or you're going to get an error. And the error will happen if you didn't do this step. So one thing that's kind of great about the CLI is it's not going to accidentally, you can't think you're doing okay and drop user secrets somewhere when you haven't configured this. You'll actually be warned and given an error that it can't even search for a list, and it'll tell you, you'll get red text out there on your command line, and you'll know, oh, shoot, I forgot to do that. Go back and add your user secrets ID. So once you've done that, if you try to list them at the beginning, you'll get nothing. But then you can go and you can set a user secret from the command line. .NET user secret set, and then two strings, or a string and a value. The string is obviously the key, and then the first one, and the second one is your value. Notice that here, again, we can nest our user secrets. You don't use the dot operator, you use the colon operator. One thing that's frustrating about user secrets in general and application settings in general is that you have to use a different delimiter for nesting things. So like in environment variables, you're going to use a double underscore because you can't use the colon in every setting. If you're out in Azure, you use like a dash dash. So in different, you have to, depending on the environment where you're working with your application settings and nesting, you need to double check and make sure you look up what your delimiter should be from the command line. And in most circumstances, the colon will work. So food service settings as the parent level, colon, and then a subproperty called API key. So now I'm going to add that's a secret. I don't want everyone to have my API key. Okay, so now if I do this and I were to go back and call user secrets list again, I'm going to actually see this. Now where all this stuff is stored is in a file called secrets.JSON. If you right click in Visual Studio or you right click in VS Code and you say I want to edit my secrets right there in the IDE, that's what it's opening, right? It's opening your secrets.JSON file. But the important aspect of this is that that secrets.JSON file does not live in your solution or your project at all. If you look closely, I know in VS Code, I'm usually in VS Code, and I know there it actually will show you the full path where that file is. I don't know if it does it in Visual Studio because I don't usually use Visual Studio very often anymore. But this secret.JSON file lives on a Windows environment. It lives under app data. You'll have your user-specific app data. There'll be a Microsoft folder under there, and then a GUID folder for whatever your secrets ID is, and then a JSON file. On an environment like on your Mac, you're going to be under your home folder. There'll be a home/.microsoft/ whatever your GUID is, and then the secrets.JSON file. Point is, it doesn't live in some hidden dot folder inside your project or in your solution. It's not living in the properties folder or in the .VS Code folder. It is completely outside. It's not going to show up as in a change set. It's not going to be committed at all, which is awesome because you can't accidentally commit your secrets. There's two downsides to this. One is, well, there's three downsides. One is there is some onboarding. When someone new comes to your team, these secrets aren't in source control. So you need to make sure that people configure their own. Part of the onboarding or documentation when you add someone new to your project or your team is you need to make sure people know that they're going to have to configure user secrets so they can run the application properly. They're going to have to set those up themselves, and there's going to have to be a little bit, it's not difficult, but you got to make sure people know to do that. Because if they just clone the project down to their own local development environment, they're not going to get a secrets.JSON file. It's not there. They'll get the user secrets ID because that's in the CS.PROJ file, but then they'll have to configure their secrets so they can run on their local environment. That's issue one, okay? Issue two is this is still a plain text file. Okay, it's a plain text file. It's in a secret location, but it's not that secret. Like I know where it is. Now you know where it is. So if your system is compromised, if your dev box is compromised, anyone's gonna be able to go and find it and read it. It's not an encrypted file at all. It's just text. So don't use production secrets in development. Always have different secrets, right? Don't use the same credentials. I know that seems like common sense, but I can't tell you how many times I've come across people who are using the same, the same information for when they go to production. So now, yeah, it's not checked into source control, but it's still there, and I can still read it if I get a hold of your machine. And then lastly, like I said, it's a dev-only thing. So what happens when you go to prod? Well, you need some way to manage those secrets in production, and it's not going to be user secrets. And the answer there is there's a lot of different ways you can do it, and it all depends upon where you're deploying your application. If you're in Azure, you can use Azure Key Vault, but if you can host your ASP.NET Core applications in AWS, and there's an AWS Secrets Manager service. There's a Google Cloud key management system. There's Docker secrets if you're running things in Docker containers. There's third-party products like HashiCorp has Vault, right? There's a bunch of different ways that you can go about doing this in production, and it's really up to you. It depends on where you're hosting your applications, and it depends on what kind of services you want to use to do it. You just have to pick something. Unfortunately, that's not automated because there's no way for the web framework, there's no way for ASP.NET Core to know where you're going. The default host builder, as I've said earlier, knows that you're building an ASP.NET Core application, so user secrets by default are enabled. You don't have to do anything special. If you're using the default host builder, you don't have to do anything special to enable user secrets in dev. But you do have to look up for your chosen production strategy. You'd have to look up how you'll configure that thing in prod because there's no way at development time to know through any default where it is you're going, okay? Next, environment variables. This doesn't really do anything other than it's a tree and out in the environment. But environment variables are also getting loaded by default. And by the way, that means all of your environment variables, all of them. Any environment variable that is on the machine or in the environment where you're running your application will be available in the configuration for your application. There's a common belief that it's actually just the .NET underscore prefixed environment variables that get read and the ASP.NET Core prefixed variables that get read. That's not true. It is true that your host configuration will read .NET and ASP.NET Core prefixed variables for setting things up like environment and various other stuff. Those prefixes matter because the host itself, it gets configured to do certain things automatically, and those prefix variables we read. And remember, only the .NET underscore stuff is only for .NET Core 3.1. So if you're in ASP.NET Core 2.x, again, .NET underscore prefix variables, that's not a thing in ASP.NET Core 2. It's all ASP.NET Core underscore because it was all a single web host, remember, not the generic host and then your web defaults. But either way, the application itself is going to read everything. And you can prove this to yourself at runtime if you actually decide to inspect your configuration, and you'll see that when it comes to your environment variable provider, you're going to see not just the ASP.NET Core underscore environment, for example. If you have other random things on your dev box that are environment variables on your local machine, they're all going to be there. That's not necessarily a big deal. You're not running your development machine in production, but you need to be aware of that because wherever you are running your production app, any environment variable available to that environment is going to be available to your app's configuration. So keep that in mind. And then not only do you have the environment variables in your environment that are being read, but we can add our own. So the launch settings file, for example, which would live inside the properties folder in your project in Visual Studio, or the launch.JSON file that can live inside the .VS Code folder if you're using Visual Studio Code. Both of those allow you to add your own environment variables that get picked up that aren't actually variables to your full dev box. You can add your own custom environment variables at the project level that will be read at runtime if you want. Now, those are the defaults, but there's a lot more than that. You can also configure your own stuff. So let's say instead of wanting to use my settings files and my user secrets and my environment variables and command line args, if you're self-hosting running from the command line, those are in there by default as well. What if I want to have other stuff? Well, I can create my own host builder, right? And just like I can have my own host configuration, I can call this very, very lengthily named method configure app configuration. And there's also a configure web configuration method if I want to configure the web host. And there's more than just adding JSON files. I can do that. I can add a JSON file here, and if instead of app settings, I just want to call settings.json, that's fine. I can add that JSON file and read configuration settings from there. I can add XML files. So if I really miss web config and I want to see something that looks and feels like web config, I can have a config XML file or call whatever I want. That file, as with any of these, it can be optional or not. And I can read from there. There's also a configuration provider for any files if anyone uses the INI format for settings files. You can add an ini file and it'll read that. One that I think is really interesting is this in-memory collection. This thing is pretty cool. If you're setting up test projects, you can create a dictionary of string and object, or string to string or string to object. Create in memory right there in your code a dictionary, and then you can load that stuff into your configuration. So if I want to have a special test project, say what if these things happen in this different alternate universe, and I want to test various settings, I can do that. And I don't have to mess with settings files for that. I can have my test project load up a specific dictionary of app settings and load them in that way. And again, by the way, even though in this slide I show new host builder, I don't have to do that. I can rely on the default if I want. So I can still take my default host builder and then call the configure app configuration method after that. And then it's no different than what happens if in the default settings, right? Where if I have a different setting in my dev app settings than my standard app settings, then just the last one in wins. Same deal here. So I can add more stuff on top of what I got by default, if I so choose. Okay. So all of that comes in from all these different configuration providers, and now I have this big magic box. that has all of this stuff. Instead of just looking at a web config, now I'm looking at settings files and in-memory collections and whatever else, environment variables, secrets, both user secrets or production secrets out of somewhere like my key vault. How do I get that stuff back out of the magic box? All of it is jammed into, at runtime, you're getting an object that's typed to configuration root, but that's an implementation of the iConfiguration interface. And all of the stuff that we've loaded from all the configuration providers goes here. When I said before that if you want to inspect and see that all of your environment variables from your whole dev box are actually in the app, this is what I'm talking about. And if you haven't done it before, it's kind of neat to look at. So once you get into your startup class, you can inject iConfiguration and look at it, and you can inspect that thing, and you'll see, and it will actually list it in order, in the order you added them. You'll see a settings file provider that has APPSETTINGS.JSON, and you can, and it's enumerable. You can open it up and you'll see all the key value pairs that came from that. And then the next thing in your list will be maybe your APPSETTINGS.JSON, and then your secrets, and you'll see them listed one after the next. And you can kind of inspect and see what's in your configuration. In code, there's a lot of ways we can get stuff back out of iConfig. First off, and the easiest, although not necessarily the best, is that iConfiguration itself, let's assume for a moment that I've had iConfiguration, by the way, is registered. We're going to talk, there's kind of a chicken and egg problem here, because iConfiguration during the host builder process actually gets configured into our container. It's registered, and I'm able to access it and inject it. So let's assume for a moment now I'm in some class where iConfiguration has been injected, and I have access. Well, I can call a typed generic method getValue, and I can say setting one. Remember from the very first AppSettings.JSON file, there was that one-off setting one and value one. I can call getValue, say I expect a string back, give the name, and I'm going to get value one back. Or again, using the colon delimiter, I can look at nested properties, say I want to get back my foo service settings API key property. I expect a string, so I call config.getValue, and I'm going to get that ABCDE 1, 2, 3, 4, 5. Notice one of those values came from my AppSettings.JSON file. One of them came from user secrets. Doesn't matter because they're all together in my iConfiguration object. I could also, and this is important in a moment when we look at better ways to handle leveraging our configuration, I can also call getSection. And that's going to bring back an iConfiguration section object that itself has some properties and methods off of it. It is itself enumerable. So if I say get the section for foo service settings, I'm going to get that whole block back. And it's going to have, for example, off that section, I can get value and type it to an int, ask for the timeout. I no longer have to have foo service settings colon timeout because I've already gotten the foo service settings chunk back, and I'm going to get that integer value back. I'm going to get a 60. That is all easy, fairly basic stuff, but it's not great. And the reason why it's not great is it's aside from the fact that it's kind of bulky, having to dig through and get things and piece out one chunk at a time that I want for my configuration. I'm also assuming that I've got iConfiguration available to me wherever I have it. I'm assuming the demo class has iConfiguration available to it, and then I want all of my configuration available to the demo class. And maybe I don't want all of my configuration available to every single class where I need to get values out. So the way we handle that in ASP.NET Core is by following the options pattern. The options pattern is a means of taking pieces, individual chunks of options, if you will, for my application and making just those pieces that I want available to the different services or classes that need them, providing just what I need and nothing else. It works like this. First off, assume, and it takes a few steps to get there, assume first off that I create a class called foo service settings. Now, this is a simple POCO. Nothing more. There's nothing fancy about it. It has 4 properties. And these are the properties that we saw came from some of the various configuration providers we looked at earlier. I have a URL, which in dev, we would expect to have that developer version of it, of the API URL that we got from the appsettings.development.json. It's going to have a rollback, which also came from there. It's going to have a timeout, which we got from the parent level appsettings.json, and that API key, which came from user secrets, or in production comes from presumably our key vault or whatever. Simple POCO. Now, again, just for a little longer, for the time being, let's assume that I have access to all of my configuration. Well, instead of getting each individual piece, I can take my config and call getSection. We already saw one example of that a couple slides ago. I can bring back the whole section from my foo service settings, and then the config section, that the iConfiguration section interface, in addition to having a getValue and getChildren and that sort of stuff, also has a bind property. and that bind a bind method. And the bind method is going to take whatever object I pass in this case my POCO, and it's going to attempt to name match the names of the properties of that POCO against the keys that are available in that configuration section. And if it finds a match, it's going to assign the values from my configuration to the properties of my object. And if there are sections of my config that don't have matching property names in my POCO, that's okay, it'll ignore them. And if I have properties that I'm hoping to get in my POCO, but that just aren't found, like let's use, for example, the rollback property. Let's say I'm not in development and I never set a rollback key or rollback property in my configuration, that's fine. It'll assign the default value. In the case of rollback, false, the default value for something that's Boolean. And in the case of an integer, it'll be a 0, that kind of thing, right? So we're going to get default values if it's not found. It won't blow up. It's fine. Now, if I then inspected my options object, we're going to see that what I get is a perfectly hydrated object that has all the stuff out of my config, not just the timeout or the key, but the whole thing, because I bound it from my configuration setting that came out of iConfiguration. Okay, great. We're partway there. We're not all the way there. And the reason for that is because I'm still assuming, remember back here, I'm still assuming that I'm passing my configuration around everywhere. We don't want to do that. But to see how we use something like iOptions, an options service or options provider, we need to first take one step back and start diving into services as a whole and how we register services in an ASP.NET Core app. And so we're finally going to take our first look at the startup class. Now the startup class, by default, again, if you just load up an empty project, is going to look something like this. We're going to have two methods on it, a configure services method and a configure method. The configure services method is actually optional. You don't have to have it at all. It doesn't have to do anything, and you don't even have to have it there. Assuming you do have it, that is where we register our services with our container for things like for IOC, for our DI. Configure, which we'll talk about in a little bit, is where we handle building the actual application pipeline, all the middleware for handling and servicing requests. We'll come back to that in a bit. But let's start looking at configure services. Configure services is going to take the iService collection as an input parameter. Now, has anyone used in the past Unity? Again, I'm used to asking the question. I know I can only see a few hands, either Unity or Structure Map, AutoFac, things like that. Probably most of you have used one or more of these. They aren't gone. They're not dead. But the difference between old-fashioned ASP.NET and ASP.NET Core is that IOC, dependency injection, is a first-class citizen in ASP.NET Core, so you don't have to use these. The built-in dependency injection services and systems that come with ASP.NET Core are not as full-featured. It's lighter weight than you might get out of something like AutoFac, and you may find, there's no built-in, say, assembly scanning, some of the other cool stuff you can get with some of these other libraries, and you can use other libraries in conjunction with what comes out of the box, but for a lot of basic scenarios, you don't need those. And so the iService collection is effectively our entry point that we use to register services and interfaces with our container in ASP.NET Core. What's that look like? So we're going to take a look at how we would use the startup class. First off, I do this, I think, every time. This is one of the very first things I do every time I start a new ASP.NET Core app. You don't have to do this, but I can't think of a time when I haven't done it. The first thing I do is I inject my iConfiguration into my startup constructor. By default, it's not there. But it's available. You actually can also inject into your startup constructor your iHost environment and your iWeb host environment. Any of those three things can be made available through constructor injection to startup if you want them. I always inject iConfiguration and then I make it available to my startup class. So when I say before, assume from what that we have it, in startup we do. Now, once we've done that, one thing you can do inside the configure services method is call configure off of the iService collection. Configure is not registering a new service or interface with our container. What it's actually doing is it's registering that POCO, that foo service settings, with my options provider. What it's actually doing is taking the same stuff we did before, where I showed that you can instantiate a foo service settings object and then go get that section and bind it, right? And then bind the values from configuration to the object. That's what's happening here. Okay, but instead of doing it one-off, I'm saying I want you to go ahead, take that configuration section, bind it to a foo service settings object, and make it available to my options provider. That's what services.configure is doing. Once I've done that, we don't need to pass iConfiguration around anymore. So now I can go into a class like a hypothetical foo service, and foo service is going to have, I grayed this out, but foo service is going to have a foo service settings field available in it. And in my constructor, instead of injecting iConfiguration and passing all that stuff and making my entirety of my app configuration available to this class, I'm just going to pass in iOptions and type it to foo service settings. The one property that comes off of that iOptions interface is value. So the iOptions now is going to go, it's going to look at what it bound from configuration. And when I call settings.value, that is going to be an instance of my foo service settings object. And now I have only that. And I didn't make anything else about configuration available to my class. I only passed in what I needed for my foo service and nothing else. It's cleaner, safer. It's the preferred pattern. Now, iOptions in and of itself is still not perfect. iOptions is a singleton. And ASP.NET Core, one of the many lovely things about ASP.NET Core is that configurations are reloadable. So I can modify environment variables at runtime without having to reboot my whole app. And I can modify what my configuration, my application settings are at runtime. The trouble is with iOptions, it's a singleton. So the first time I configure and set it up, if I reload configuration values later, I'm not seeing the new values. A couple other options that are available, other interfaces that you can inject instead of iOptions. One is iOptions Snapshot. iOptions Snapshot is not a singleton. It is scoped per request. So when I inject iOptions Snapshot of foo service settings, every request response cycle that comes into my app, I'm going to recheck and rebind what's in my configuration. So if I have reloaded some values inside my config, I'm going to get the updated values instead of whatever was there when I first spun up my app. So that's nice. The other thing that iOptions Snapshot supports, which is not supported out of the box with just the iOptions interface, are named options. So if I want to have special options, I can do a standard bind. I can call .configure and just bind whatever I get out of that config section for foo service settings. But I can also, back in startup, I can configure named versions of my options. So I can configure a foo service settings and call it my special settings and give it some other configured version of that object that isn't necessarily what's just coming out of my config. And then I can, in my dependent class, when I get into my foo service, I can load iOptions Snapshot, and I can choose to pull back that named version of the options and not just the thing that came from iConfig. Okay. And lastly, there's an iOptions Monitor. iOptions Monitor is pretty cool because it is a singleton, just like iOptions is. And sometimes that's what you need, because even though configurations are reloadable, what if my foo service itself is a singleton? What if I have some other class that is registered as singleton? Then having iOptions Snapshot doesn't do me any good, because yeah, it'll reload every time I ask for one, but the service that is depending on iOptions Snapshot is only being loaded once. So instead, I can inject iOptions Monitor into my singleton service, and iOptions Monitor will not only be registered as a singleton and will not only support named pairs, but first off, I can call .currentValue instead of .value, and it'll always read and rebind whenever I ask for it what the actual value of my configuration is right now. And it has an onChange event. So I can actually respond. I don't even have to repoll it. I can respond. When something in my configuration does reload, I can respond to it in real time in my singleton service. Okay. Now that's just the options. Which really, even though it's the service and is registered with our container in a way, is just one part of this, and it's still part of configuration. Now let's move away from configuration and talk about registering our own services. The kind of stuff that we are used to doing is something like AutoFac, right? Where I have an I service and then a concrete implementation of that service, and I want to register that so I can inject that around my app. Well, there's a lot of ways you can do that. So let's go back to my simple foo service that we looked at before. And let's say it has a couple of very simple things. We know it has an API key. So let's say that there's some connect property or connect method, and then I get back a list of foos, a simple service still. But here, my foo service on the right is implementing an iFoo service interface on the left. Interface-based programming, just like we would see in ASP.NET prior to when we had core. Well, we can take this and without using anything like AutoFac or structure map or anything else, using the built-in dependency injection and the iService collection that we get in ASP.NET Core, we can register them right there in startup. So instead of calling services.configure, now we're calling, for example, add scoped. And I'm going to pass in 2 type parameters, the interface that I want, that I'm registering, and the concrete implementation that I want to get. And now once I do that, if I inject my iFoo service into some other dependent class, excuse me, then I'm going to get some default constructed version of the foo service object. I got something in chat. Oh, okay. Thanks, Paul. The add scoped bit we can do it a couple different ways. Sorry. So one is we can do it this way and say, hey, I want to register this iFoo service interface and I want the foo service class. We can also if we don't want to use type parameters, you can similarly pass in actual types, system.type, into the add scoped method and do a type of. Another thing you can do, which is pretty useful, is I can say I want to register iFoo service, but instead of the default version of a foo service object, I can specify exactly how I want that thing configured. So now when I ask for an iFoo service, inject iFoo service, I want you to give me a foo service instance, but maybe configured in a certain way or receiving these specific arguments in the constructor. So I can be very specific about how I want that thing configured when I request the iFoo service elsewhere in my application. And scoped is only one of the different lifetimes. So if you're used to using, say, AutoFac, which I think has a whole lot more than just these 3, you might be used to more flexibility. The built-in lifetimes available in ASP.NET Core, there's 3 of them. The scoped, which you see in the middle, which is scoped per request. Every time I have a new request response lifecycle, I'm going to get a call in, and I'm going to create a new version, and then that version of my injected dependency is going to live for the length of that request, and it's going to go away. Standard request response scope. There's also a transient, which is per instance. Every time I ask for one, I'm going to get a new one every single time. And then there's singleton, which is a singleton. I create it once, and then for the lifetime of my application, that singleton will persist. So I have those 3 choices. Now, there are also extension methods. A lot of these we see every day when we build our own ASP.NET Core apps. Take, for example, take the add DB context. Anyone, if you use entity framework like EF Core in your ASP.NET Core apps, you might see something like this: services.addDB context. Well, addDB context is still really behind the scenes, just doing a whole bunch of add services. But there's a lot of other things going on here. The reason the addDB context extension method was made available with entity framework is because there's a lot of other stuff that has to happen. And so we're not just adding an application DB context to inject, we might be doing a lot of other configuration behind the scenes, right? For example, using SQL Server, getting our connection strings, all that kind of stuff. We see extension methods like this when we need to specifically configure something more than just adding the service and moving on. Another example of this is some of the stuff you get with MVC. You can do services.add controllers, add razor pages, controllers with views, or if you want all of it, add MVC. Now, add MVC, again, before ASP.NET Core 3, add MVC was your only choice. These guys didn't exist in ASP.NET Core 2. But they're the preferred approach now because it breaks it down a little bit more. If you really combine add razor pages, add controllers with views, you end up basically with add MVC. But what these are all doing is, again, instead of you having to go through and specifically pick out a whole bunch of different services, all the different dependent things that you need to run MVC, they already went to the trouble for you of creating an extension method to register all those things at once for you. And what's really great is we can roll our own. I'm super psyched. I get excited because when I was first doing things and wanted to add my own services, I didn't realize when I very first started with ASP.NET Core, I didn't realize I could kind of, I guess I should have, but at first I didn't realize I could create my own extension methods and how easy it really is to do. Let's look at that because it's very straightforward. First, we create some sort of a static class. By convention, we're going to call it FOOEXTENSIONS. It doesn't really matter what we call it, but let's call it FOOEXTENSIONS. And inside our static class, we're going to have one method, also static, this add foo. Add foo, first off, you'll see is an extension method of the iService collection. Second of all, it's going to return that iService collection back after we're done with it. The reason for that is because, again, by convention, we like these things to be chainable. We want to be able to say services.addDB context, .add identity, .add MVC, .add foo. And we can chain them all together by making sure that when we're done, we pass the iService collection back out to the caller. In between all of that, we look at a few things we might do. Let's say that we haven't talked about a factory, but let's say I have some sort of a foo factory that I need for handling foos in my application. And I want that factory to be a singleton. So I'm going to register my foo factory as a singleton to my container. Then I'm going to go ahead and add the scoped lifetime for my foo service to my container. And maybe I'm also going to have a specialized logger. I want to have some sort of logging strategy for my foos. So I want to add a singleton foo logger that specifically not only is a singleton, but is going to take in some sort of configurable path for where that log goes. You'll notice on the back here, not only is it an extension method, but I'm passing in a string. And I'm going to use that to configure my logger. So much like add MVC does a whole bunch of stuff to set up controllers or razor pages and views and all the things we want behind the scenes for us, I can do all that same stuff here. When I'm done, back in startup, all I have to do is call add foo. And it's going to do the same thing that something like add DB context might do. And I can chain it right where I want it in my startup. And now, not only does it make my startup cleaner and easier to kind of parse through and read, but I can now take that same thing and just like you have an add identity or add auto mapper, just like people can take these individual chunks, make their own libraries, and allow you to share them into other people's applications. You do that here with foo as well. Okay. Questions on any of that before we get into the pipeline? Any questions? Has anything else come through, Pete? Because I'm not really watching. Or does anyone have any questions? Because I've been just talking. We good?
Yeah, we're good.
Awesome. All right, so let's talk about pipeline. This is the last kind of bit here. Pipeline has to do with middleware. Now, middleware, I don't know why, but middleware used to intimidate me. It felt like some sort of thing that I didn't really understand what it was doing. And I know it's all part of a pipeline, and I'm playing with and screwing with the requests and the responses. They come and go in and out of my app. And I don't know how that stuff works, but it turns out the middleware is also actually it's really simple. If you've ever looked or spent any time with the docs for ASP.NET Core specifically, you've probably seen at some point maybe a chart, kind of a little flow diagram that looks something along the lines of this. That sort of shows how middleware works and what a pipeline looks like with an ASP.NET Core application. Now, it's a lot of stuff on the screen, but really all that's happening is that each piece of middleware is just a component. It's really just a class that does some stuff. And each class, each component of middleware is going to be lined up in order in some sort of pipeline that's going to take a request. So say Kestrel is going to get a request in, it's going to do some stuff, and it's going to compose an HTTP context, and it's going to pass that context into the first piece of middleware. The middleware is just going to invoke a method, and it can read that context. It can modify, right? It can do things and write to the context. It's going to do whatever it wants to do on the way in, and when it's done, it's just going to pass it to the next class waiting in line. And it's going to go from middleware 1 to middleware 2, middleware 3. It's going to make its way all the way down the line, and eventually, when we get to the end of the pipe, that last one will pass it into our application code to actually execute our app. And when the app is done and we return a response from the app, before the response goes back to the client, it's going to go right back out through that pipeline in reverse order. So I went in 1, 2, 3, and on the way back out, I'm going to hit 3, 2, 1 and go back out. And just like every piece of middleware has an opportunity to inspect or do something to modify that context on the way in, it also gets a chance to do so on the way out. Now, some middleware won't have the need or like to do things both on the way in and out. It only needs one or the other. Some things might take like a piece of logging middleware that might want to read or make some log on the way in and note, hey, we started something, and I'm going to read and write something to a log we started, and then when everything is done, the way back out, I want to write back out at the end as well. Not every piece of middleware does that. The other piece about this is you'll notice each one, these are asynchronous, and each one has this await next. Because what's really happening is these middleware pieces, these components all stay in scope. So I run the inbound logic on middleware 1, and then if I'm middleware 1, and I say, I'm going to pass it off, and I'm going to wait right here. And I'm going to pass to middleware 2, and I'm going to wait my turn. And at some point, it'll come back to me on the way out, and then I'll pick up where I left off and have my outbound logic. So each one of these just does the stuff before the await next, and await next is just invoking the next piece of middleware. Okay. Sometimes, like I just did here in middleware 2, I might not call await next. What happens then? Well, it's not a big deal, but it's important to know that if await next isn't called, and if instead I go from my inbound logic right to my outbound logic, that's fine. Effectively what happens here is my middleware 3 just never gets invoked. My application code never gets invoked. I just move right back on out, and I pass it back out the pipe and send something back to the client. That's okay. Sometimes you want that. We call it like a short circuit piece of middleware where we say, well, we didn't need to keep going. Now, if you have a piece of middleware that always does that every single time, well then, what's kind of the point of having your application, right? You're never actually executing your application code, and you're never seeing any of the middleware after it. But there are times when conditionally you want that to happen. Look at a couple of examples. So now, let's move to the configure method. This is the other half of our startup class. We already saw configure services. Configure is mandatory. Configure services, remember, was optional. Configure is going to accept an iApplication builder. That is the builder that's going to actually assemble the pipeline for our app, and an iHosting environment. That's going to let us inspect and see what is our environment. Are we in dev? Are we in production? Optionally, there's an args parameter that comes after this. So if you want to inject anything else, other services you've already injected, you need anything else to go into this configure method call, that's fine, because there is an args parameter that so you can add other things if you need. One version of a standard template might have something, we're going to kind of scroll through a few of these, might look like this. First off, we're going to check if we're in development. If so, that developer exception page is just a piece of middleware. App.use is the convention, right? So app.use, my developer exception page middleware. If I'm in dev, if there's some sort of exception or an error, don't send me back some friendly, smiling, 500 page that we'd serve to a real user. I want to see some nicely formatted information that tells what's going on. Give me my trace. Give me everything. I want to see what happened so I can actually look into it. But only if I'm in dev. Otherwise, maybe let's make sure we're using strict transport protocol. I want to make sure that I'm not allowing any insecure traffic in or out. Okay, once we're past that, let's say we want to use HTTPS redirection. That's an example of another piece of middleware. Let's look at this one here, the static files. Static files is an example of short circuit middleware. So the use static files middleware is going to look at the request coming in and say, are you looking for a static file? Are you looking for an image? Cool. If so, I'm just going to serve that right back. And if that's the case, there is no await next. It will actually stop right there and pass it back out. Now, it'll still pass back out through the HTTPS redirection middleware. It'll still pass out through our use developer exception page middleware on the way out, if those things happen to do anything on the outbound logic, but it will not go to the app. It won't go to our routing. It won't hit our endpoints. And that's a good thing, because if we actually try to pass a request for a static file to MVC, things are just going to blow up. Like, it's not going to know what to do with it. Now, if we're not asking for a static file, then await next does get called and we move on. But this is an example of where, like, the order really does matter. Okay. By the same token, let me go back here a second. On here, this order really matters too. There's a reason that we use the developer exception page middleware first. First. Always first. Because what happens if something happens before that? What if I put a piece of middleware before that and something blows up sooner? Well, if I never got to configure my developer exception page middleware and something happened before I ever got there, then it's going to spit back out an error and I'm never going to get to see my stack trace. I'm not going to see what's going on. So that's an example of, we want to make sure that the very first thing that gets seen on the way in and the last thing it passes through on the way out is the opportunity to use that developer exception page in case something blows up in between. So again, an example of why the order of these things matters. And then here, things like use routing and use endpoints. Well, this is setting up like my MVC. Okay, I'm setting up my controllers. Again, you used to just see use MVC instead of all of this, and you would have like use signal R and all these other helper extension methods that existed before ASP.NET Core 3. The preferred method is not to call use MVC anymore, but to rely on use endpoints. The reason for that is because now in a single call, we can configure all of our endpoints in one place in a single piece of middleware. So by calling use endpoints, one piece of middleware is managing our routing tables, not only for controllers, and we can define map controllers, by the way, is just for using attribute-based routing for controllers. You can map default controller routes in other ways, the way you might pass in an actual route and strings and things like that. But you can also map signal R hubs inside use endpoints. You can map health checks on your application. Those are just endpoints. And by using the endpoints middleware, you can put all of those endpoints in one place and have a single piece of middleware that manages those. Now, again, celebrate. It's funny, since Keller, my son's on this call, it's kind of funny because I always say, I use this picture because it makes me smile, because yay, we're so happy. This is like what my kids, I feel like, look like when they come home from school every single day. They're so excited to show me the thing they built and the thing they did, and they're really happy, and they're a total mess. But now I get to tell that little bit, and my kid's on here. So yeah, dude, I I use this picture because you come home from school looking like this sometimes. So we can build our own middleware extension methods just like we could do with our services. There's a few ways we can do that. If we want to do it inline, you can invoke middleware either using something called app.run or app.use. The key difference here is that app.run is always short circuit middleware. App.run does, you'll notice here, it is still asynchronous. Everything about our middleware pipeline is asynchronous, but it's only taking the context. It's not even taking a next delegate to await. So there is no pointer, no delegate that looks at the next piece of middleware. If I call app.run, anything that happens after that is never going to be called. Maybe that's okay. If I'm running a simpler app and I just want to say write something out to the response, great. So app.run, in this case, I might do some other stuff, and then I'm going to say I'm done. I'm going to write that text back onto my response. I'm going to send it back out. Okay. Alternatively, there's app.use. App.use can be short circuit, but app.use also takes in not just the context, but takes in that next delegate. So this looks more like what we saw in that chart before, where I'm going to do something with the inbound logic is anything I want to do to inspect or modify my context on the way into my application. And then at some point I'm done doing all that. Maybe again, I want to build my own custom logger as an example. So I want to check some things, maybe record a timestamp, write something to a log, do some stuff, get ready, and then say, okay, now I'm going to wait right here. And then when it comes back out and say, hey, you're done, good. I'm going to inspect it, what the results were, maybe get another timestamp, write something else out to the log and pass it off. And I can drop this app.use block right in the middle of my pipeline, just like anything else. So in this case, maybe I'm going to call my custom middleware after my HTTPS redirection, but before I handle static files. For example, I inject it wherever I want. And I want to make it really clean and use real extension methods, just like we did with our services. We can build our own middleware because again, right, middleware is just a class. It's just a component that manages our stuff. So let's make a foo middleware class. Look how simple this actually turns out to be. We need only a couple of things. First, it's going to have a read-only delegate. That request delegate, again, serves as the pointer to whatever is going to be next in the pipeline once we configure a pipeline. So when I have next at runtime, next is going to, in the case of, say, this guy, next is going to represent my static files middleware. So I'm going to take that delegate in, and I'm going to make sure that I assign that delegate and make it available to my middleware in the constructor. That's easy enough. And then I'm going to have, again, one method. It's asynchronous. It's going to return a task, and it's just going to be invoke. My await next is really shorthand for saying take that next delegate and call invoke on that next thing. That's all that await next really does. Is it's shorthand for saying go get my next piece of middleware and call the invoke method on that piece of middleware. So that's what I'm doing. So presumably someone before me in the pipeline said await next. It came to my foo middleware. My foo middleware says, okay, I'll invoke. And you'll notice that that chunk in the middle there is really just the same thing that was in my app.use block before. It's just, you know, assume I have some other content, not just comments, but I lifted that entire piece of code and I drop it here in my invoke method. That's it. So that's piece one, is creating my foo middleware class. That's my middleware. And then the second part of that is I'm going to have, just like I had foo extensions for my services, I'm going to create a static extensions class for my middleware. And all that is going to have is a static use foo method. That's it. And inside foo, notice though, again, it's an extension method on the iApplication builder because that's what that app was that's back in my startup class. It's an extension method there. And I am going to return it so that I can chain things if I want to. So I'm going to return my iApp builder back after I'm done. So in this case, all I'm doing, and you can call this, by the way, right in startup, just like you can have app.use, you can call app.use middleware and give it a middleware class if you want, but it's kind of nicer to abstract that away. So now I've created a use foo method. I'm going to say use this piece of middleware, and back in startup, all I got to do is that. And all use foo is doing, again, is saying, take that simple class that I'm going to do stuff to a request, and I want you to use that piece of middleware when you build out your pipeline. That's all it's doing. And you can build your own to do whatever you want to do. So I've said this several times. I keep this in here because for some reason, this image makes me laugh. I know I say order matters several times. When I first built this talk, it was back, the first version of this was around Halloween anyway. And I was like, I need to find an image for order mattering. And I found that. Like, that's what came up in my Google image search. And it was too perfect. So the order really does matter, right? If we don't configure our developer exception pages and our exception handling at the very start of our pipeline, we might miss handling some exceptions that happen outside of that part of the pipe. If we try to configure SSL, HTTPS before we actually ensure strict transport, strict transport won't do us any good, right? If we try to configure our MVC stuff, our endpoints, before we configure our routing middleware, it won't work. All those things matter. So you really need to think about the order. Otherwise, you're building a pipeline that doesn't do any of the things that you hope it'll do. So it's very important to pay attention to that. That said, I don't even know, because my phone is like dead. I don't even know what time it is, but I think we're coming up on about time, if not well past it probably, because I know I talk a lot. But all I say here is, look, dig into this stuff. Like, dig deeper into how these things work. Take the time to understand what's happening behind the scenes. I said all of it is open source, right? It's all open source. If you see something and you see an extension method or you see something in ASP.NET Core, you're like, that's kind of weird. I wonder what it's really doing. Go find out. Like, sometimes it's amazing to watch. An example of something that's amazing to look at is actually configuring startup, like what use startup, that simple use startup, angle bracket startup, what that does. Because it's pretty ingenious what they've done in terms of reflection, to go and find a class, ensure that it's there, ensure that it has exactly one instance of that configure method, ensure that configure services is available. If it's not there, to inject its own configure services empty method. And it's amazing what happens just to allow you to designate a startup class. And when you see the way those things work and you understand more about what's happening behind the scenes, it allows you to leverage all that in a way that you can really not just take whatever they give you out of the box. Like, the templates get you a long way, but there's a lot more you can do than just hack a whole bunch of stuff into your configure services method. You can make things a lot nicer and configure stuff and make things reusable and build your own components once you understand what those components are doing and how they work. Okay, and keep on learning, keep paying attention, because now, like I said, when I first built this talk, people were first starting to look at ASP.NET Core 3.0. Now we've got ASP.NET 5 in preview, and things keep moving, and things are always changing. So keep paying attention to how these things change over time. We do a pretty good job of keeping things backward compatible, but that doesn't mean that the way you're doing things today is the best way to do it as the framework evolves. So keep paying attention to all of that. I've taken tons and tons of your time, so thank you for hanging around and listening. If you have questions, we can chat. I'm happy to stick around on this Zoom or on another one. If Pete's got to get going, that's fine. If you want to reach out to me, it's at Jeffrey Strauss on Twitter, or you can feel free to email me. If you use the Start Me Up hashtag, you don't really need to, but if you do, I'll definitely see it that way if you want to ask questions, start dialogue about that. And that is really it.